name is Tommy, and today we're talking about reaction direction. So, we have our graph here of the reversible reaction between x2 plus y2 yields 2xy. So first, we need to see at T1 which is favored, products or reactants, or the forward or reverse reaction. So, as you can see, our xy, or our product, is greatly increasing during this period, or at this point, while x2 and y2 are both decreasing. So our reactants are decreasing and our products are increasing. So that means that the forward reaction is outweighing the reverse reaction at this point. So that means that the forward reaction is greater at this point. Now, identify at what points the reaction is at equilibrium. So, we see that we're wanting to look for where these lines level out. And that lets us know that those values aren't changing and that the forward and reverse reactions are stabilizing and are becoming more equal. So, we see that T2 and T3 we're at equilibrium. From T2 on, we are at equilibrium. So both T2 and T3 are at equilibrium. Now, we have to draw diagrams of initial and final with representations of the molecules in these in the concentration or solution. So, if we represent this with 10 molecules each, we'll see that 0.6, 0.3, 0.1, that adds up to 1. So we can just represent each one. Since we're doing 10, we can just do 6x2, 3y2, and 1xy. So 1xy, 3y2, and 6x2. So that's what it looks like initially, but finally we can see that we have vastly different concentrations. We see that xy is 0.5, x2 is 0.4, and y2 is 0.1. That still adds up to 10, so we can do 1 per molecule, or 1 per 0.1 molar concentration. So we can have 5 xy's, 4 x2's, and 1 y2. So, 1 y2, 4 x's, or x2's, and 5 xy's. So if we look at these, we can see that the products increased with only 1 xy over here and 5 over here, and the products decreased with 6 x2's over here and only 4 over here, and 3 y2's over here and only 1 over here, which is what we'd expect from a forward reaction favored reaction.